Good morning, class. We begin today where we left off yesterday in the online classes. We were talking about acids and bases. We did the definitions, now the classification. This also to some extent was done. I'll repeat it once again. Classification of acids. Various types of classifications are there. First of all, organic and inorganic acid. That is the classification based on origin or source. Organic, as the name is suggesting, organic acids means those which originate from living organisms, like say formic acid, found in red ants, Formosa it is called. So organic acids like formic acid, acetic acid, oxalic acid, etc. So these are weak acids, and besides hydrogen, you know that hydrogen is the essential element present in an acid. So besides hydrogen and oxygen, it also contains carbon. Organic acids also contain carbon. And they are weak acids. Example, formic acid, HCOOH. Inorganic acid. Next is inorganic acid. Inorganic acid or mineral acids. Inorganic acids are also called mineral acids. Now mineral acids which are found on the minerals that are found on the earth's crust, like carbonates, nitrates, sulfates, etc. From that is the origin. So carbonic acid, sulfuric acid, nitric acid, HCl, hydrochloric acid, all these acids these are strong acids. It's not essential that they contain a carbon. Only carbonic acid contains a carbon, which is also a weak acid. So HCl, HNO3, H2SO4, etc. These are mineral acids. They are usually strong acids and they don't contain carbon. Exception is H2CO3. This contains a carbon atom and it is a weak, unstable acid. So this is one way of classification. Next is the second classification is based on the molecular composition. Second classification is based on molecular composition. If the molecule contains only hydrogen and no oxygen beside the other non-metal, then it is called a hydracid. For example, HCl, HBr. These are called hydracids. What are these? These are hydracids. Hydracids. Oxygen is not present in it. But if oxygen is present, then oxyacid, like HNO3, oxygen is present, or H2SO4, oxygen is present, H3PO4, oxygen is present. So if oxygen is present along with hydrogen and the non-metal, then it is called an oxyacid, and if not, then only hydrogen is present with the non-metal, then it is called a hydracid. Next is the concentration of the acid. From here, bases also can be classified on this basis. So we'll write acid over here. Concentration. Third classification, concentration. This totally depends on the amount of acid present in the solution. That is, percentage. If the percentage of acid is higher and water is less, then it is called a concentrated acid. And if water percentage is more and the percentage of acid in the aqueous solution is less, then it's called a dilute acid. So concentrated acid Two categories again, concentrated acid and dilute acid. In concentrated acids, the percentage of acid is much higher and the water content is less. Whereas in dilute acid, the water content is more and the percentage of acid in the aqueous solution is less. Now usually how much, say, if the dilution is less than 1 mole per liter. 1 mole per liter, 1 mole means what? The gram molecular mass. So if it is less than, if concentration is less than 1 mole per liter, then it is a dilute acid, and if it is more than 1 liter, then 1 mole per liter, then it is a concentrated acid. So concentrated acid and dilute acid, and same is the case with a base also. If the concentration of the alkali or the base is more and the water content is less, then it is called a concentrated acid, and if more water is present than the number of alkali molecules, then it is called a dilute alkali. So acid and alkali both can be classified like this, concentrated and dilute. Do not confuse with concentration and strength. Strength is a totally different concept. A concentrated acid can be a weak acid and a dilute acid can be a strong acid also. So now we will talk about the strength. The next classification is strength of the acid. How do we classify this? Strong acid and weak acid. Strong acid and weak acid. On what does this strength depend? This is not, the previous one was concentration of the acid molecules present in an aqueous solution. This depends on, the strength depends on the concentration of hydrogen ion or hydronium ions present in the solution, in the acid. So on what will that hydrogen ion or the hydronium ion depend? The concentration of hydronium ion or hydrogen ion will depend on the degree of dissociation. If the acid completely dissociates in water molecule, in water, then what happens? Then you get a high concentration of hydronium ion or hydrogen ion. If suppose you have taken an acid H, and what is it producing? H3O plus Cl minus. The whole means whatever HCl is present, the whole is dissociating into H plus and Cl minus ions. Then naturally the concentration of hydrogen ion is high, and if hydrogen ion is high, then hydronium ion also will be high. So if the concentration of, if it is a total complete dissociation and the percentage of this concentration of the hydronium ion or hydrogen ion is high, then it is called a strong acid. And where the dissociation is less, means only partial dissociation takes place. Partial dissociation takes place. Then what happens? Then it is called a weak acid, because the percentage of, then the concentration of hydrogen, if partial dissociation, that means concentration of hydrogen or hydronium ion is less, and if hydrogen and hydronium ion is less, then it is a weak acid. So this degree of dissociation will be, suppose I am giving an example of the weak acid. Suppose acetic acid, CH3COOH. Acetic acid, this will dissociate into acetate ion CH3COO minus and hydronium ion H3O plus. But the degree of dissociation is less, means only partially this molecule dissociates, means the number of molecules present in the solution, aqueous solution, only partially it will dissociate. All molecules will not dissociate into acetate ions and hydrogen ions. So in that case, the percentage of the concentration of H3O ions will be less, and if the concentration of H2O ion is less, it is called a weak acid. Now what is this degree of dissociation? Alpha. Degree of dissociation, strong acids, degree of dissociation is very high, we just now said. So alpha, this is degree of dissociation, this is equal to number of molecules ionized or dissociated upon total number of acid molecules. Actually, this is number of acid molecules ionized upon total number of acid molecules into 100. This is degree of dissociation. If the degree of dissociation is less than 30, then it is a weak acid, and if it is more than 30, then it is strong acid. Same stands for the base also. If the base ionizes completely, like NaOH, KOH, and furnishes a NaOH, which will dissociate into Na plus and OH minus. On complete dissociation, it will be furnishing a concentration, high concentration of hydroxyl ions, and if hydroxyl ions are present in excess, then it will be a strong alkali or strong base. Soluble bases are called alkali. So if it's dissolving in water, means it is naturally an alkali, we call it an alkali. So this is how we, on the basis of strength. So on the basis of strength, how do we classify the acids and bases? Depending on the degree of dissociation. If it is complete dissociation, then it is a strong acid or a strong base, and if it is a partial dissociation where the alpha is less than 30, then it is called a weak acid or a weak base. Next is the basicity of an acid. Next classification, basicity of an acid or acidity of base. Now this one, what is meant by basicity of an acid, or we call it basicity is 1, monobasic acid. First we will deal with monobasic acids. What are monobasic acids? Monobasic acid, or we say the acid's basicity is 1. Basicity is 1. When the acid, when dissolved in water, furnishes only one hydrogen ion per molecule of acid, then it is called monobasic acid. So if it is furnishing only one hydrogen ion, so first point is that it furnishes the acid in aqueous solution, furnishes or produces only one H plus or H3O plus per molecule of acid. Then it is called a monobasic acid. Next is furnishes only one. How do we know that? See, HNO3 suppose. HNO3 plus H2O. This furnishes H3O plus NO3 minus. So how many hydronium ion it is furnishing? Only one. So HNO3 is a monobasic acid. So it furnishes only one hydronium ion or hydrogen ion. Secondly, it contains one replaceable hydrogen atom, and dissociates in one step. Replaceable hydrogen atom means if